All right, so this lesson is the last lesson before we get into the problem-solving lesson and then the test. Now, this one is dividing 4-digit numbers. It's honestly the same thing that we've been doing, except more steps. So do this with me. Watch this. What if I was going to do, let's say, 74 divided by 3. 74 divided by 3. First thing I do, 3 goes into 7 2 times, because 2 times 3 is 6. 7 minus 6 is 1. Bring down my 4 and start over again. 3 can go into 14 4 times, because 4 times 3 is 12. And 14 minus 12 is 2. So 24, remainder 2. Now, what if I was doing 3 into 748? I've just added a number. Same deal as before. I just go, okay, so 3 can go into 7 2 times, because 2 times 3 is 6, and 7 minus 6 is 1. Drop down my 4 and start over. 3 can go into 14 4 times, because 4 times 3 is 12, and 14 minus 12 is 2. Okay, at this point, this is identical. The only difference now is I have another thing to bring on down, and then I gotta bring it on back again. So now I have a new number. 3 goes into 28.
9 times.
Okay, because 9 times 3 is, and 28 minus 27 is 1. Anything else to bring on down? No, so now I am done. Remainder 1. So what if, again, I was putting 3 into 7,489. 3 can go into 7 2 times, because 2 times 3 is 6, and 7 minus 6 is 1. Bring down my 4 and bring it on back to start over. 3 can go into 14 4 times, because 4 times 3 is 12. 14 minus 12 is 2. Bring it on down. Bring it on back. 3 can go into 28 9 times, because 9 times 3 is 27. And 28 minus 27 is 1. As of now, I just did the exact same thing that I did with this one. Except the last question I asked myself is there something else to bring on down? And this time, yes. Bring on down the 9 and bring it on back to start over again. 3 can go into 19. 6. 6 times 3 is 18. And 19 minus 18 is? Anything else to bring on down? No. So now it's remainder 1. So no matter what you do, it's always the same process. And the main reason that you can get it wrong is because you lose your place. That's why drawing the arrows and showing everything is really important. When there's something that's this big, even mentally, it's hard to keep track of some things. Unless every single one of these numbers was a multiple of 3, sure, I could do that. No problem. But this is something that I have to keep track of because I'm doing a lot of things over and over again. And I know that there are plenty of other things that I have done in my life, like counting out a stack of something, and I lose place I forget what the next number is because I heard something. And all of a sudden, I can't remember if I said 15 or if I said 16 as I was counting. And I have to start over again. How many times has that happened to you? Sure, because our brains are wired that way. I heard a noise. Someone asked me a question. Something happened that I lost my train of thought. And then the train went careening off the tracks and landed into a ditch and caught on fire. That's how it feels sometimes. And the only thing you can do is start it over again. So if you get lost, no matter what part of it you are in, just go, okay. Let me start over. So here's what I did. I put 3 into 7, so 2 times 3 is 6, and then 7 minus 6 is 1, and then I dropped down the 4, and I made it 14. And then I put 3 into 14. Just talk your way through it. If you keep talking your way through it, going in order, divide, multiply, then subtract, bring it on down and bring it on back. Look for these arrows. If you notice that you didn't draw an arrow, maybe that's where you got lost. So there are ways for you to help yourself out here. These arrows are not just for show. They can help you stay organized. They're like a bookmark for you, okay? So let's practice some more 4 digits. 2,871 divided by 9. Now, the very first thing that I notice, 2 is less than 9. So 9 is not going into 2. 9 is going into 28. Meaning my first spot will not have a number. 9 can go into 28 because 3 times 9 is... I still write my 27 the same way under the 28. 28 minus 27 is... And then I start over again. 9 can go into 17 once. Sure would be nice if it was 18, but it's not. 1 can go into 9. 1 times 9 is 9. 17 minus 9 is... And now I bring down this one and bring it on back. Now it's asking me to put 9 into 81. I can do that. 9. And there we go. I'm done. That wasn't so bad. What about 2,486 divided by 4? 2,486 divided by 4. Again, first thing I notice,
2 is smaller than 4.
2 is smaller than 4. 4 is not going into 2, so 4 is going to have to go into 24. Oh, hey.
6 times.
This is something that I can do maybe halfway mentally. 4 can go into 24 how many times?
6.
6. Which would mean 6 times 4 is 24, and 24 minus 24 is 0. So because I know that, and I'm confident in this, I'm not going to write anything else. It's just going to end up in zeros anyway. It's showing my work. It's proving a point. But this is proof right here. 6 times 4 is 24. And now, look, this is all zeros, so the 8 would come down. How many times does 4 go into 8? Twice, because 2 times 4 is 8. So the last thing is, how many times can 4 go into 6?
1.
Okay, 1 time, because 6 minus 4 is...
2.
Now, I still could have done this little part right here in my head. I wrote it down to show you that if you need to, you can write it down. It's fine. When it gets easier like this, you can absolutely do some of it mentally in your head. Because 4, for the first 3 numbers, can go into all of them. They're all multiples, so it works. When you got something like this, yeah, you got to write it out. I'm not doing that much numbers in my head. That's a big fiery train crash right there. But for this, when I start seeing that it's all going to work, I get a bit more confident and I'm going to give it a try. If doesn't work for me and I get frustrated, all right, I'll start over again and I'll do my work this time. Let's try 691 divided by 9. Obviously, 9 cannot go into 6, so it is
69.
69. 9 can go into 69
7 times.
7 times, because 7 times 9 is 63. And 69 minus 63 is 6. Drop down my 1. 9 can go into 61. No, 6 times, because 6 times 9 is
54.
and 61 minus 54 is
7.
there we go, 76, remainder 7. And last one, 1,140 divided by 4. 4 is not going into 1, so it's going into 11. 4 can go into 11 2 times, because 2 times 4 is
8.
Where am I writing that 8? Under the first one or the second one?
Second.
Second one. Technically, we'll say there's a 0 there if that helps. What's 11 minus 8?
3.
Okay, bring down my
4.
4 is now going into 34. How many times can 4 go into 34?
8.
Because 8 times 4 is
32.
32. Don't let this get you. Sometimes when a number is so close, we sometimes decide that it is. And sometimes this is where we can mess up our remainders or the rest of it, because we're like, oh, 8 times 4 is 34. Our brains can be mean to us sometimes. So that's why you have to keep yourself on track and make sure. I've seen this mistake happen before. That's the only reason I'm bringing it up. Okay? Or sometimes I'll see a 32 here and this 8 is actually a 7 or a 9. So we've all done that. I've done that too, yeah. So just always be aware and check yourself. That's why I always say because, so that you're saying the fact again. 4 can go into 34 because 8 times 4 is 32. And 34 minus 32 is?
2.
Bring down my 0. And now 4 is going into 20.
5 times.
5 times because
5 times 4.
5 times 4 is 20. And 20 minus 20 is 0. All right. Now, another thing that you need to remember. Your brains tend to freak out when a number can't go into another number. But let's say, can 8 go into 3?
No. 0 times.
Aha, it can go into 3. 8 can go into 3 0 times. That's what you got to remember. Don't say it can't, because then you want to leave a blank spot or you don't put anything there. Or then you get stuck and there's that train crash again. Say it goes in 0 times, because 0 times 8 is 0. Like that. When you think in that way, it's going to get easier for you. Also, don't forget to do the last bit. Sometimes people like to just skip the last number altogether. You run out of steam, and that's okay. But always go back and check your work to make sure, okay? Are we freaking out or are we feeling good?
Good.
Good.